In this video, we're going to start to introduce a new topic, which is that of vectors. Now, vectors are something we covered some of the basics of back in National 5 Mathematics. So the first video or two, we're going to just refresh your memory of these. We're going to look at some of the basics that we need to be able to do, handle and work with in order to be able to be successful when we move into higher level mathematics with vectors. Now the first thing we're going to look at in this video is something called position vectors, because we need to be able to understand what these are, work with them and calculate them in order to be able to do anything else when it comes to vectors. Now I've said vectors a few times. There's two key things that we work with in mathematics that we need to understand and know what the difference is between them. These two key things are a scalar and a vector. Now a scalar is something which represents a size of an object or a size of a thing. So these could be thought of as mathematical concepts including time, length, area and speed. A vector not only has a size, but it also has a direction. So for example, a journey or a displacement from point A to point B. This is the difference between a vector and a scalar. It's this key thing here is that it has a direction. Vectors don't exist without telling you where something goes, how a journey pans out, or how something looks. When we're working with them, we also have to know that key concept I mentioned at the start, a position vector. Now a position vector is something which describes the journey from A to B. Now imagine I set up a scenario like this. I've got a point A and a point B, and I want to know what the vector between the two of them is, i.e. the journey between the two of these points. Now we can name a vector in several different ways. So the journey from A to B can be named in any one of these ways. So AB with the arrow above it tells us it's the journey from A to B. Bold A, where what we'll do is name this as being the A. But if you notice here, it's actually quite difficult for me to do bold with a pen. So the alternative way of writing this is this last one here, A with a line underneath it. Now these are all used in different ways to name vectors, so we have to be aware of all three of these. Some textbooks and exercises use bold, some use arrows, some use the underline. We have to make sure we use the appropriate one and understand what each of these means. Now a three-dimensional vector will look like this when it's panned out. It'll be an X, a Y and a Z component. So it'll be a component in each direction. So you can imagine if you set up a three-dimensional system that looks like that. So you've got your X axis there, your Y pointing off and your Z up. This will tell you how far along, how far up in the Y and how far up in the Z your journey takes you. It'll tell you where to go in terms of all three of these sets of axes. And we can actually use B and A here to calculate it. So we can use A and B to get this vector A to B. But in order to do that, we need to know the vectors of A and B. We need to know the position vectors that describe these points to then be able to use them and calculate the vector between them. So if we set up the scenario like this, where I've got an A and a B, I've still set it up with my Y and my X axis as normal. I'm just going to work in 2D at the moment. And I want to tell you that A's position is given by XY, so that's where it's plotted on our system, and my B's position is going to be given by AB, so that's where it's plotted in our system. Now the position vector tells me the journey from A to B, so if I was to name this one here as my position vector AB, this is what it would describe. However, I've got to calculate this, but if you think about it, we can use other journeys to describe this. Now, to name A and get the position vector for A, I have to look at the journey from the origin up to A. So I have to look at this journey here. So in order to do that, I have to name this position vector. And in order to name it, we name that O to A, because we're going from the origin to the point A. And to get the position vector of this, we take the coordinate of A and write it in vector form. So for 2 dimensions, it would be XY like that. If it was a 3D one, we'd just add on our Z component underneath. I also need the second position vector here. So the position vector giving me the coordinate B, i.e. we'd name this one O to B, which is given by our AB. Now again, if it was a 3-dimensional one with a C part of the coordinate as well, I'd have a C part of my 3D vector there. So we need our position vectors to describe these points, which are given by these properties here. Now in order to get my vector A to B, which I don't know, I have to use the vectors I do know. Now if I want to go from A to B, think about it, I can go backwards on my vector A and then follow the vector out to B. So in order to do that, I can go backwards on my vector O to A, and I can then go up this way on my vector O to B. Now to calculate this vector, if you imagine that our vector O to A is given by this, well, we're going back in our way. So this vector here is given by negative x, negative y. This one going out here is still the same at A to B. So in order to complete the journey, I take my negative OA journey and I add on my position vector O to B. I can use that to calculate it. Now remember, we said we could also name it other ways. This vector here we could name as A with the underline, and this vector here we could name as B with the underline. It'll just help us get a bit more shorthand. And that then allows me to write this using these, which then tells me that I can calculate my vector A to B using this, but I know that this O to A is given by A and this O to B is given by B. So it's going to be negative A plus B. Or, the better way to write it is the vector B take away the vector A. So I can use this to calculate my position vector of displacement between any 2 points. I can use their position vectors from O to A and O to B, or whatever the coordinate is, and I can use that to calculate it using this property, which will then give me my position vector between the 2 points. And in order to do that, I just subtract them from each other. So I have AB take away the vector xy. So I just take the top components away, so A take away the x, and the bottom components away, B take away the y. And that there will give me the position vector between the 2 points and how I maneuver from them. So easy way to demonstrate this. This is a lot of jargon to throw at you. Easy way to demonstrate it, show you an example. So I've got an example in 2D here for the first one, and I've got a 3D example here at the bottom. Imagine for both, I want to calculate the position vector AB. Well, we remember from the last slide, the position vector from A to B is given by B take away A. Now what we need is we need these two position vectors B and A. Well, these are the position vectors that get us to these points here. So my position vector for this one, remember, we write it as a vector, is 4, 5, because we're going from the origin to there, so it gets us to that point. This one here for the B, again, it's the same idea. It's going from the origin to the B point, is given by negative 1, negative 3. So I've got my two vectors. Now I want to use this property here to calculate the position vector A to B. So I know that A to B is going to be given by B take away in terms of my vectors. So now I just plug them in. My B vector, negative 1, negative 3, and that's going to be take away the A vector, which is 4, 5. And as we showed last time, it's just X parts take away each other, Y parts take away each other. So it's negative 1 take away 4, negative 3 take away 5. So negative 1 take away 4, negative 5, negative 3 take away 5 is negative 8. So what that tells me is my journey from A to B, what I have to do is I go back 5 in the X direction and down 8 in the Y direction. So that would tell me how I travel between them. Again, same idea for this three-dimensional scenario. The only difference is I've got an extra component. I've got a Z part. But again, it's still the same idea. It's still B minus A. So I still want a position vector to get to A, and I still want a position vector to get to B first. So my position vector to get to A, based on this coordinate, is negative 1, 0, 4. And my position vector to get to B is given by 5, 2, negative 2. What I now do is calculate AB based on that. So I've got A to B equals the B minus the A, and then we just plug in the values. So I've got 5, 2, negative 2, take away negative 1, 0, 4. Combine the two of them in the exact same way we did here. Again, the only difference is we've got a third component. So I've got 5 take away negative 1, 2 take away 0, and negative 2 take away 4. So 5 minus minus 1 gives me 6, 2 minus 0 gives me 2, negative 2 take away 4 gives me negative 6. So that there is my vector from A to B. So what that tells me is to go from A to B, I go along 6 in X, up 2 in the y direction, and then down 6 in the z direction. It tells me how to make that journey and what I need to do to go. These are key things we have to remember about vectors and the difference between them. We have to be able to calculate these position vectors and be able to write any position vector for a coordinate. And you base that on the relationship between the coordinate and the origin. You have to make sure you do that.